Okay guys, today's video is going to be on probability, and it's going to be on listing outcomes. Okay, so we'll do 3 or 4 lessons on probability, some new stuff. This should be a reminder for what you've done a little bit last year. Okay, so let's go through 3 examples, 3 exam questions, and then I'll post through the work. So Mickey goes to a coffee shop. He chooses 1 drink and 1 snack. Write down all the possible combinations that he could do. So you got drink here and you got snack here, all the different combinations. Now, don't just think, oh, you could have a tea and a muffin, a coffee and a brownie, and a juice and a crisp. So 3. No, it doesn't work that way at all. You need to think, what if you listed out every single possible combination, how many are there going to be and what are they? So I'd go tea, coffee, juice. And so I'll probably put T, C, J. So T, C, J in my table here. And then the top line, I'd put M, B, C, and P. M, B, C, and P, all representing the different food there. So he could have a tea and he could have a muffin. So he could have a tea followed by a muffin. He could have a tea followed by a brownie. He could have a tea followed by a crisp. He could have a tea followed by a pastry. He could have a coffee followed by a muffin. I think what you'll see here is I'm literally listing out every single possible outcome there could be. And finally, with the juice, could be a juice with a muffin, a juice with a brownie, a juice with the coffee, crisp, and a juice with the pastry. So they're all there. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 different outcomes that you could do from those selections there. Right, a question that a lot of you got wrong in the mock exam was this, or something similar. Adam, Ben and Cyrus all run in a race. How many different possible results could there be? Okay, a lot of you just put one result or whatever. We need to now think logically and say, right, well, we got Adam. I'm going to label it A, B, and C, by the way, just to make my life a little bit quicker and easier. So if Adam finished first, then Ben could have finished second and Cyrus could have finished third. That's one possible outcome. What if Adam won, but rather than Ben finishing second, Cyrus finished second? So you put Cyrus here, which therefore means that Ben would finish third. Okay, so they're the only combinations we can do if Adam wins. So let's now say Ben wins. So let's put Ben here. So if Ben wins, Adam could come second, Cyrus come third. Again, Ben wins, but this time rather than Adam coming second, Cyrus does. So Cyrus comes second, Adam comes third. So they're all combinations we can do if Ben wins. Last one, what if Cyrus wins? Cyrus wins, Adam could come second, and Ben would come third. Cyrus could win, and instead Ben comes second, and Adam comes third. So what you've got here, you've got 1, 2, 3, 4, 5, 6 different possibilities. 6 different possible results that could happen from this. Okay? Right, last example here. Right, I have 2 dice, however they are both unusually numbered. Dice A is numbered like that, dice B is numbered like that. I want to throw both dice and add the scores together. What are my possible outcomes? Right, I want to throw both dice. Now, it's got 6 faces on a dice, but I'm not going to put 1, 2, 3, 4, 5, 6 because they're actually labelled like this. So I'm going to go 2, 4, 6, 8, 10, 12. I'm going to label that dice A. Okay? And then this dice here, dice B, is going to be 1, 1, 1, 6, 6, 9. I'm going to label that dice B. Now we have a table. It says here I add the scores together. So therefore I need to add whatever scores I get. So if I throw dice A and I get a 2 and throw dice B and I get a 1 altogether, that's going to be 3 because that score, they specifically tell us to add those scores together. So 4 and 1, 5, 6 and 1, 7, 8 and 1, 9, that's 11, that's 13, 2 and 1, 3, In fact, these are going to be the same as the one above. 9, 11, 13, and so will that, because that's a 1 as well. 3, 5, 7, 9, 11, 13. Right, 2 plus 6 is another option. So 8, 4 plus 6, 10, 6 plus 6, 12, 8 plus 6, 14, 10 plus 6, 16, 12 plus 6, 18. 6 as well, so therefore they're going to be the same as above. And lastly, 2 plus 9, 11, 4 plus 9, 13, 6 plus 9, 15, 17, 19, and 21. Okay, so therefore they're all our possible outcomes that we could get if we throw these two dice and add them together. What's the probability that I get a total of 11? So now I look at what I have in front of me and say, how many 11s can I find? Well, I've got one 11 right here. I've got another 11 here, another one here, another one here. So I have 4 11, but that is not my final answer because 4 isn't a probability. 4 out of something. So I count up how many of these numbers that I have. And I've got 36. I simplify it to 1 out of 9. So that's how I deal with listing outcomes in probability. Okay?